Hello, this is Mr. Muller for lesson 10-8, combinations and permutations. So there's three different kind of probability we're really going to find. One with combinations, one with permutations, and then one with compound events. Okay, so compound events are the easiest. Those are the ones we're most used to finding. So if we're finding something where we have something like 5 pants and 3 shirts, how many different outfits can we make? So when we have something like that, we're just multiplying the two numbers. So if I have something like this, a voicemail system is one letter followed by a 3-digit number, less than 600. How many different voicemail passwords are possible? So it says one letter, so I know there's 26 times numbers less than 600, so 0 to 599. So we're looking at 26 times 600, it would be 15,600 possible combinations. So a problem like that, we are just multiplying our two options for what we have. Okay, so compound event consists of two or more simple events. Sometimes the order in which a simple event occurs is important. This time, it doesn't say anything about the order. It says one letter followed by 3 numbers. So that kind of, it says the letter has to go first. So we wouldn't pick 0, 0, 0, A. It'd have to be A, 0, 0, 0. But there's 15,600 different combinations for it. Something like this, an English test contains 5 different letter essays labeled A, B, C, D, E, and you're supposed to choose 2. How many different ways are there to do this? Alright, so again, you have 5 questions on this test, A, B, C, D, E, you have to choose 2. How many different ways can you answer 2 of those questions? And here are all the different combinations, except we're missing the fact that A and B and like B and E are the same. Something like D and A and D are the same. So 16 different ways to do it, but some of them are repeating, so there's only really 10 different ways to do it. So 5 different letters, A, B, C, D, E, we have to pick 2. 5 times 2 is 10. Before we get into combinations and permutations, we need to know what a factorial is. Okay, so something like 5 factorial, that means 5 times 4 times 3 times 2 times 1. And all those numbers multiplied together would be 120. Okay, 2 factorial would be 2 times 1, so 2. 3 factorial would be 3 times 2 times 1, so 6. 4 factorial would be 4 times 3, so 12, times 2, 24, times 1. Okay, and then once we add that 5 factorial, 24 times 5 does give us that 120 from before. So factorial just means we are multiplying all the numbers before it all the way to 1. So here's a example of a permutation. Suppose you want to make a 3-letter password from the 5 letters A, B, C, D, E without repeating a letter. So without repeating a letter kind of makes it a little more difficult for us to choose one because we can't have 2 A's or 2 B's or 2 C's or all 3 of one letter. Okay, so this is a permutation. So for our first letter, we have 5 options. We could pick A, B, C, D, E. Second letter, we have 4 options because we already choose one from the first time. And the third letter, we have 3 options because we already picked 2. Okay, and our formula for when we're doing something like this is going to be, so this only works for permutations. So we're going to do n factorial divided by n minus r in parentheses factorial. Okay, so n is our number of choices that we have. So in this case, we have 5 letters. R is what we're restricted to. So we're restricted to only picking 3 for our password. So that's where the 5 factorial, because we have 5 letters to choose from, A, B, C, D, E. And then n minus r, so n is still 5, minus 3, because we're restricted to only pick 3 letters, is 2. So that's where the 2 factorial comes from. So 5 factorial minus 2 factorial, or 5 factorial divided by 2 factorial. And again, you kind of see how they did it a little simpler here, where they both have a 2 and a 1 on top and bottom, so they crossed them out. So really what's left is a 5 and a 4 and a 3 on top. So 5 times 4 is 20, times 3 is 60. So there are 60 different ways I could set that kind of password. Okay, so a permutation, order does matter. Okay, so you can't have something with 2 A's or 2 B's or 2 C's, something like that. So order matters for permutations. Okay. So another one example like this. So order matters for this. So a group of 8 swimmers are swimming in a race. Prizes are given for first, second, and third. So we have like a gold, a silver, and a bronze. Order is going to matter for this. It's not just saying top 3 or something like that. We want to know who finishes first, second, and third. So remember, we're using this formula. So our n, we have 8 swimmers, so 8's going to be on top. And then n minus r. So n is still 8, and we are restricted again to 3 places. We can't give a prize to everybody. So 8 minus 3 is 5. And so again, we're crossing off 5, 4, 3, 2, 1, because those are the ones that are repeating. And then we're left with just 8 times 7 times 6. And so 8 times 7 times 6 is 336. Combination is kind of the same thing, except order does not matter. So that would be like if you can rearrange or reuse those letters twice. If you just want to know who top 3 were, but you didn't care who was first or who was second or who was third. So not really when order matters. Okay, so for something like this, 4 people need to be selected to help out in a classroom out of the 15 people in the classroom. So our formula almost looks the same, except we're going to add one thing since the order does not matter, and that is another r factorial on the bottom. Okay, so now it looks like this: n factorial divided by r factorial times n minus r factorial. Otherwise, it's the same kind of problem. So again, our n is going to be 15. There's 15 kids in the classroom. Our r is 4, so there's the 4 outside the parentheses. And then 15 minus 4 is 11. 15 being the number of students, 4 being what we're restricted to pick. I can only pick 4 people to help. So 15 minus 4 is 11. And then again, we just plug it into our calculators, and we end up figuring out that there are 1,365 options to pick to see who's going to help in the classroom. So remember, combinations don't need a specific order. Permutations do.